The next video is measuring length. Okay, so we're going to talk about all the units and measurements of length. Okay, and first of all, it's meters. So we're going to base everything on a kind of physicsy type thing because it's science at this level. And physics is all in a slightly different. I'm going to talk about the units for bio and the units for chem as well as we go through just to compare. So the length, the base one is meter. Okay, so 1,000 meters is a kilometer. A hundredth of a meter, as in one hundredth of a meter is a centimeter. Okay, 1/1000th is a millimeter, and that's a big number. 1/1,000,000th is a micrometer. Okay, and a nanometer is even smaller. Okay, so that basic, but the real thing you need to know is 1,000 meters is a kilometer, and 1 centimeter is a hundredth of a meter, and they're the ones you use all the time. Okay. Unit of mass is a kilogram. Okay, now we'll start with microgram, very, very small, as you can see. 1 ton is 1,000 kilograms, 1 gram is 1,000th of a kilo, and 1 milligram, you can see, is a very small number there as well. But again, what are you going to use in the lab all the time? You're going to use grams and you're going to use kilos. So the really important thing is this one here. Can you convert a gram to a kilo? Well, 1 gram times 1,000 is a kilo. And then 1 kilo divided by 1,000 is your grams. Okay, right. We require different instruments to do different masses, and I'm going to mention something really important here. A mass of several grams can be measured using a mass balance. That will be used in labs in your school. A mass of kilograms can usually be done using scales. Okay, now my students try and write scales all the time. I would prefer they use mass balance because we're in a lab. Okay, but if you do write scales, you've got to remember the S on the end. A scale is different to scales. Scales is this. A scale is like a musical scale or something like that. So keep the S on the end. Right, measuring volume. The unit of volume is the cubic meter. And again, that's a physicsy type thing. So if you do physics, you'll use meters. If you do chemistry, you'll do centimeters cubed and decimeters cubed. So 1 decimeter cubed is 1,000th of a meter cubed. Okay, 1 centimeter, as you can see, is 1, 2, 3, 4, 5, 6. So it's a millionth. Okay, and then a litre is 1,000th of a metre cubed. Notice the units of this one, these two, are exactly the same. That means 1 decimetre equals 1 litre. And what you'll really need to do is change centimetres cubed into decimetres cubed. So centimetres cubed, 1 centimetres cubed, okay, is 1,000th of a decimetre, is 1,000th, got there, of a litre. So basically, if you want to convert this to a decimetre, okay, divide by 1,000, this to a litre, divide by 1,000. If you want to convert a litre to a centimetre cubed, times by 1,000. Want to convert a decimetre to a 1 centimetre cubed, 2 centimetres cubed, you times by 1,000. Okay, so the conversion from here to here is times by 1,000, from here to here is times by 1,000, and the conversion from centimetres cubed to decimetres is divide by 1,000. Centimetres cubed to litres, divide by 1,000. And that's the main thing you need to know. Okay, and a millilitre, very small. Right, let's go to measuring the volume of liquids. So we know all the units and all that kind of stuff. But what's the volume of liquids? We do that by using a measuring cylinder. So it's poured into the measuring cylinder and you look at the mark on the scale. Notice it doesn't say scales, it says scale. Okay, the S is important. Measuring cylinders are usually marked with millilitres or cubic centimetres. Millilitres, okay, is an old way of doing it, and in primary schools you talk about millilitres. Please stop using millimetres. We want centimetres cubed. Okay, and then we put a measuring cylinder here. So this is a nice measuring cylinder. All right, and so this is your scale, and these are called your graduations. And the closer together your graduations are, the better your results are, and they're more precise. And we'll talk about that later when we talk about precision and accuracy. Okay, but better to have close graduations. And also when you're measuring with a measuring cylinder, you always try and fit the measuring cylinder to the volume you've got. So for example, if I'm measuring 25 centimetres cubed, I'll use a 25 centimetre cube measuring cylinder. I don't use a 250. A 25 would measure out 25 centimetres cubed. Okay, try and keep the volume and the size of the measuring cylinder very similar. Right, okay, so measuring the volumes of liquids has a lot of error in it. And one of the errors is meniscus. So when liquids are in the measuring cylinder, they form a little meniscus. It's kind of a crescent, and you must read to the bottom of the meniscus. So here is your meniscus. So you need to read at the bottom. And can you see that's very different? So this is on the bottom of the meniscus is on the line, but the top is above the line. So it's really important you read the bottom. Okay, so bottom of the meniscus, really important. Okay. Parallax error. Parallax error is when you're measuring the volume of a liquid. You've got to be aware of it because it can give you an error, a mistake. This results from the measuring cylinder being at an angle. And to avoid it, you've got to look at it at a right angle. So let's have a look at this example. So here's a measuring cylinder. You're looking down from it, you will get 19.62. If you look up from it, you get 19.82. You look at a right angle to it, you'll get 19.7. So you've got to get down to the level of your table and look. Okay? And that's how you avoid parallax error. And if you want to answer a question in the exam, say you're looking at it at a right angle. We're now going to go on to measuring the volume of certain solids. The more will happen in the density video that we talk about, but for now, let's talk about just doing regular and irregular solids. So if an object has a simple shape, its volume can be calculated, and it will only be something simple like a cuboid like this. And all you're going to need to do is the length times the width times the height. Just remember to use the units they give you. Okay, length times the width times the height. Now, measuring the volume of irregular solids. There's one way of doing it in this video, but there's another way of doing it in the density video. If the shape is awkward, it can't be calculated, and so you lower it into a partially filled measuring cylinder. Partially filled, then means if you drop, for example, a stone into it, the volume will rise, and then the difference between the start and the end is the volume of the object. Okay, if it floats, you might have to push it down with a stick or something like that. But that, again, makes it a little bit inaccurate. So here's your example here. Measuring cylinder, stick the rock in. The difference is, and remember measuring by the meniscus, okay, the difference is your volume of the rock. Now, taking measurements. If we're taking measurements, there's something we need to take into account. We're going to talk about this in the next video that's on errors. When taking any kind of measurement, you should try to select the equipment that will give you the most accurate value. To do this, you must select a piece of equipment with the smallest resolution or the smallest divisions, sometimes also called the smallest intervals. Now, what does that mean? So let's take an example here where we want to get an accurate reading of 15 and we want to get an accurate reading of 150. So if we look here, we can say, right, okay, we want 15. Which one can measure 15 but has the smallest resolution measuring 15? Well, that's got to be the measuring cylinder. You can see there's lots and lots of lines here. So that scale has the smallest divisions. Now we want to do 150. Well, that measures 200 and that measures 150. They've both got pretty bad scales. However, if I had to choose between these two, I would probably choose the beaker because it stops at 150. This goes up to a 200. It closely fits. But an even better way would be just to fill this 3 times because it's got a much better scale and the smallest division. Right. That is the video on measurements, giving you all the measurements and telling you how to measure and doing a bit of parallax error. As I say on the end of all these videos, please share, like, subscribe, all of that. It really helps. And I hope you find it useful.